It's day 17 of Maker Advent. Yes, we're only 7 days away from Christmas Eve, when this series will finish. Sad face. Okay, what we got today? Well, it's an odd day, which means we go into the Pi Hut Maker Advent calendar and we get the next box from the set. So let's delve into the box and have a look. Cunningly, it's on my desk already. Let's open the box on camera. Day 9. Okay, what's in the box? A black tube with 2 legs and a lot of jumper wires. What could this be? Well, let's have a look. So, day 9, full tilt. What does full tilt mean? Well, it means we've got a tilt sensor or a switch. Really, it's just like a ball bearing that when you move it around, it makes it a brief connection. Good bit of fun. Actually, I've not played with one of these before. No, I've not. I've played with magnetic reed switches. They're awesome. Really like them. But I've never played with a ball tilt sensor. Let's see. So when you tilt the sensor, gravity pulls the ball downwards and makes it roll to the other end. The legged end has 2 contacts inside which connect to each leg. When the ball rolls down to the legged end, it connects these contacts, legs, together, as metal is conductive, which then provides our Pico with a high signal. So it makes the connection, pulls high, and there you go, change of state. Just like a push button. Easy peasy. So we're not going to need much kit today. We don't need the additional breadboard, it's just a case of the main breadboard with the lights and the buzzer. And we're going to connect up the tilt sensor to pin 26. We do like pin 26, don't we? We do. So let's see, it's going to pin 26 and it's going to 1, 2, 3, 4, 5 down from the right, which I know is 3V 3 output on a Pico. So it's going to have a connection to high, so when it's normal state it's going to be low. When it's connected, when the ball tilt sensor is used, it's going to connect it to high, 3V, cause a trigger state, something happens. Let's get this built up. One moment please. Okay, the project has been built. That was an easy build. So all I've done, the tilt sensor has gone into these jumper wires, connected to pin GPIO 26 and to 3V. It doesn't have a polarity, so you can put it in either way, it doesn't matter. And it's ready to go. So, let's have a look at the code. So I'm skipping ahead with the code. I want to go to this second example. There's 2 examples for day 9. Okay, we start off with the basics, as always, the imports. From machine import pin, GPIO, import time, to add pauses and delays to the code. Basically controlling it so it doesn't all happen at once. And we've got an object called tilt. Tilt is our connection to the GPIO at pin 26. It's an input. And we're going to use the pull down resistor. So on Raspberry Pi Pico and Raspberry Pi itself, certain GPIO pins have what are called pull up or pull down resistors. These resistors are there to just pull that pin high or low as we need it. So in this case we need it pulled down, so it's at 0V, ground. So it has a reference so that when we send the pin high, 3V, later on when the tilt happens, it knows there's a definite change of state. That's it. That's all it does. Inversely, we can use pull up to pull a pin to 3V, so that when a sensor which would send a signal to ground happens, it connects to ground, changes the state, and there we go, another change of state. That's all they do. Okay, we're going to set up a counter now. This counter is a variable, tilt count, and it's set to 0, so there's no tilt. And here is the state. The state is the sensor's state. Has it been triggered, yes or no, 0 or 1? Oh, no, 0, 1, yes. While true, do this code forever. Have a short pause, 0.1 seconds. If the state is 0, so it hasn't been triggered yet, and the tilt value is 1, update tilt count variable to tilt count plus 1, so add 1 to tilt count. Then set the state to 1. Print tilts equals tilt count. In other words, print tilts equals, and then go to the variable tilt count, get the value stored in there, and put it next to it. Then we've got another if condition test here. If the state is 1 and tilt value is 0, change the state to 0. That's because if we didn't update that, it would never get back to this first if conditional test. because we changed the state value to 1 there, so it's active. It has to be 0 here. So without that being there, the loop would not progress. It just sit there and go round and round and round and never do anything again. So that's it. That's a nice easy bit of code. So I'm going to run this code. I'm going to stop it to make sure it's not running and run. So the code is running and there's the sensor. 1. Recognize it already. I'm going to invert it. 2, 3, 4, 5. There you go. 6, 7, and that's just doing it randomly. Yeah, there you go. 10, 11. So it's picking up that as movement. So you could use this sensor very basically as some sort of movement sensor. So say you wanted a pedometer to measure your footsteps when you go out for a walk somewhere, you could build it with this. That's a good bit of fun. I'm liking this sensor. It's just simple. It doesn't need too much explaining. It's just a simple on-off state. And it's something that could be quite interesting for kids to play with. Anyway, that's all for today. See you later.